Good morning, everyone. My name is Sumit Chandrasen Thorar from SY AIDS. Today, I will present my topic Basic Probability Theory, Random Variables and Events. This topic belongs to the course Foundation of Artificial Intelligence under the guidance of Prof. Dr. Krishna Kumar Sir. Probability is one of the key pillars of the artificial intelligence and data science. It helps machines and humans make informed choice under uncertainty conditions. By the end of the session, you will understand how probability contains theory with intelligent decision making. Next, we see table of content. In this, we will see objective, introduction, definition, importance, principles, probability, key characteristics, types of random variables and events, outcomes, reference, objective question, and conclusion, etc. Next, we see objective of basic probability theory. The goal of probability theory, it is a measure and understand uncertainty. It introduces experiments, outcomes, and sample space as its basic components. We also study random variables and events to describe real-life random variable mathematical. This knowledge helps analyze observability system from weather patterns up to AI models. Through this topic, we develop logical thinking and quantitative reasoning. It also strengthens our ability to interpret data and predict future outcomes accurately. Next slide, we see Introduction to Probability Theory. Probability theory is a branch of mathematical that deals with randomness. It also used to assign numbers and uncertainty outcomes and make prediction. For example, when we toss a coin, probability tells us likelihood of getting heads or tails. It's a key component in a data analysis statistics and AI algorithm. By learning probability, we prepare to handle uncertainty scientifically. It also helps build predictive models that guide intelligent decision making. Next, we see defining probability, events, and variables. In this, let's define the main term clear. A probability measures the chances of an event occurring ranging from 0 to 1. An event is subset of outcomes from a random experiment. A random variable assigns numerical values of each outcome. Together, the ideas from the mathematical foundation of uncertainty. Understanding them helps us move from simple containing problems to predictive modeling. These are the same principles that AI systems use in probabilistic reasoning. Next, we see importance of probability theory. Probability plays a critical role in many domains. It helps in handling certainty, vital for AI, economic, and medical prediction. It models real-world phenomena like reliability, time, or temperature variation, etc. It also supports decision-making in machine learning using probability algorithm. In AI, probability allows system to adapt and learn from uncertainty data. In finance, it helps measure risk and forecast the future outcomes. Overall, it bridges the gap between randomness and logical predictions. Next, we see principle of probability theory. Principle of probability theory is based off Columbus theory axiom. Non-negative probability values are never negative. Additive for multiple executive events probability simple add. These rules ensure mathematically consistent every calculation. Without this principal probability would lack of structure prediction. They the base of every probabilistic model used in AI and statistics. Next, we see probability theory concept. Several key concepts for the foundation of probability. The same space lists all possible outcomes of an experiment. Events are subset of the sample space that represent specific occurrence. Random variable assign number of these events. We also studies examination and variance to understand average and deviation. Exception shows the long run average outcome while variance shows spread together. This concept helps model and analyze random system efficiently. Next, we see probability theory concept. Several key concepts from the foundation of probability. This sample space lists all possible outcomes of an experiment. Events are subset of the sample space that represent specific occurrence. Random variable. Assign the number of these events. We also studies examination and variance to understand average and deviation. Exception shows the long run average outcome while variance shows spread. Together, this concept helps model and analyze random system efficiency. Next, we see key characteristics of probability theory. Here are the main features of probability theory. Probabilities range only between 0 and 1. Random variable convert outcomes into measured quantities. The total probability across all outcomes equals 1. It provides tools probability across all outcomes equal 1. It provides tools to reason logical about uncertainty. These characteristics make probability both mathematical and practical. They allow scientific engineers, AI models to express confidence in result in contents mathematical directly to real-world prediction and analysis. Next, we see types of random variables. There are two major types, discrete random variables and continuous random variables. In discrete random variables, we see take countable values like 0, 1, 2, etc. Example, number of heads in coin tosses. In continuous random variable, take infinite values with a range such as higher or time. Discrete variable use probability mass function and continuous use probability density functions. We understand this helps in choosing the right mathematical tools. Both types of are used in medical simulation, AI models, and engineering process. Next, we see example of discrete random variables. Let's take a simple example. If we toss a coin twice, the possible number of heads x can be 0, 1, or 2. The probability may be 0.25, 0.5, and 0.25 respectively. Since the total equal 1, x is a discrete random variable. Such variable appears in everyday problems like counting customer or errors. They are easy to visualize and essentially for probability distribution. Discrete variables are often modeled using binomial or Poisson distributions. Next, we see types of events. Events are different ways of grouping outcomes. Simple event, component event, multi-executive event, independent event, dependent event, and execute events. In simple event, contain only one outcome. Example, rolling at 1 or die. Compound events combine multiple outcomes. Multi-execute event cannot occur together. Dependent events do not efficiency each other outcomes. Dependent event, one affect the probability of another. Execute event, together overall or possible result. Understand event type is essentially for accurate probability calculation. They also form the basic of conditional and joint probability. Next we read random variable events. All are being returns. Next we will see features of probability theory. Probability theory combines logical statistics and mathematics. It can handle both small and larger data sets. However, processing large data requires heavy computation. That's why modern AI use essentially algorithm for probabilistic reasoning. Probability of it precision, but also demands careful implementation. It ensures that conclusions are based on a sound mathematical foundation itself, the language of uncertainty used to across all scientific domains. Next, we see application benefits and changes. In this, we see decision making support, mathematical framework, computational complexity, data limitation. In decision making, we see random variables helps in making informed decision when outcomes are uncertainty. They allow prediction and analysis of possible results based on probabilities. Mathematical framework. They provide a strong mathematical base for studying. This framework is essentially for application in statistics, AI, and data analysis. Computation complexity. Working with large or complex data sets and required heavy computation, essentially algorithm and computing power are often needed for such results. Data limitation. If data is incompletely and inaccurate, the conclusion becomes unreliable, good quality, and essentially data are critical for forest outcomes. Next, we see application of probability theory. In that, AI and machine learning probability models help AI predict outcomes, classify data, and make decisions under uncertainty. Example, spam detection, using Navy base, etc. Next, we see application, finance and risk analysis. used to estimate risks, return, and market trend, modeling uncertainty outcomes like stock price and credit defaults for better investment decision. Example, predicting stock price, etc. Next, we see medical diagnosis helps assess the likelihood of diseases based on simultaneous test result and patient history. Example, probability of COVID-19 based on fever and causes. Next, we see games and gambling. Probability calculate the chances of winning decision, fast strategies, and predicts outcomes in games of chance like cards, dice, and lotteries. Example, chance of rolling a 6 on a die. Next, we see ethics and issues. In this, we say probability can powerful, but it also be applied recently. Incorrect use of data or based assumption can lead to wrong conclusion. In AI, ethical probability modeling prevents unfair decision. We must ensure that transparency and uncertainty. Ethical application builds trust in probabilistic system. When used correctly, it makes decision making more fair and accurate. It important that to balance the accuracy with responsibility. Next, we see outcomes. An outcomes is the simplest possible result of a random experiment. For example, rolling a dice gives outcome from 1 to 6. Tossing a coin gives outcomes head or tail. This basic result from the foundation for all probability analysis. Outcomes are combined to form events and sample space. By studying outcomes, we can predict and model real-world randomness. Every complex probability problem begins with identifying possible outcomes. Next, we see a reference. In this reference, we can see textbook and academic course. Let's see, KP Soman Jayakar and Vijay Rijju, Data Many, Theory and Practice It, etc. There are many online education sources like Stanford University, Probability Concept in AI, Towards Data Science, Medium, articles, and Probability in AI and Machine Learning, where we use Greeks for random variables and probability theory. NPTEL courses, probability and random variable process, AI focused reference like secure rules, Cloudflare, etc. Next, there is the MC2 for in probability theory. We can see the probability of any event always lies between. There are so many MCQs added. There are subjective questions for descriptive questions like what is probability theory, what is random variable, what is an event of probability, what is sample space, etc. Now, at the end, we see what is conclusion. Basic probability theory helps to model or centrality analyze random outcomes. It plays an important role in fields like statistics, computer science, engineering, finance, and architecture. In this, we can see that to calculate probability theory is a scientific of uncertainty. It helps model random behavior and support reasoning under incomplete information. It's fundamental to AI, statistics, engineering, and finance. By understanding events, outcomes, and variables, we make better prediction, probability drives mathematically with real-world problem. It enables logical thinking, risk analysis, and informed decision making. In short, probability is the foundation of AI intelligent and predictive system. Thank you so much.